Ahead and I think we're live now. So I'm going to mute my phone here, or the microphone, and then it will put focus on you. And I'll leave the chat window. Uh, if we have questions, I'll just pop in and interrupt you.
That sounds good.
It'll switch back and forth to us, but I'll put the focus back on you. So go ahead and do your intro, and then just share your screen. We'll be listening.
Okay, sounds good.
You know what I'll do? I'll actually just tweet you if we have any problems.
Perfect, that works.
Thank you.
Thank you. Okay, let me get my screen going. Okay, perfect. So, as the name is Prox, I am a Microsoft VP for the Posh show, and I've been coaching IT for about 10 years now. I have written quite a few articles. My personal blog for PowerShell is learn-powershell.net. I do write for Hey Scripting Guide periodically. I've actually got some articles coming out for him probably in the coming months. I've also done a couple of spots on the PowerShell magazine as well as on PowerShell.org. And I'm also a contributing author for the PowerShell Deep Iceberg that came out last fall, I believe. And the chapters I wrote were focused on TCP core communication for PowerShell.
Hey, Bo. Sorry to interrupt.
Yep.
It's kind of choppy and breaking up. I don't know.
Okay.
Maybe, go ahead and try to say a few things.
Okay. This is a test of me talking. Can you hear me?
It's kind of like the audio gets really like robotic.
Okay.
Maybe if you can move your microphone away from your face a little bit, maybe sometimes that helps.
Any better? Does that sound anything sounding better, less robotic?
Are you speaking English or?
No, it's the headset and the connection probably. Is it a USB connection?
It's anyway, webcam. I have a speaker jack for the headset and mic.
Put the boom a little bit below your face. We have, if you can.
It might help it.
Okay, how's that?
A little better.
All right. I had kind of a little bit of choppiness too on third as well, kind of in and out.
It might just be the Hangout. I'll blame Google, but we'll give it a shot. Just give it the old college try.
Hey, why not?
All right. Sorry about that. Go ahead.
No, that's good. No. So to get into it, I'll be talking about basically PowerShell runspaces and what they are, how you can use them, and just kind of things in between here. Talking about various pieces of the runspace, to include the runspace pool and other various parts of it that can kind of help make your scripting easier or faster or better performance, however you want to look at it, as well as how useful it is when you're working with writing UIs in PowerShell. So what exactly is a runspace? A runspace is pretty much an instance of PowerShell that contains a collection of commands, providers, variables, functions, and other language elements that can be modified and are made available to the user. And when you're using a runspace, unlike a PowerShell job, you're staying within the current PowerShell process, and you're basically creating a new thread on that process. So why would you use runspaces? One of the biggest reasons is because of the performance. They're faster because there's less overhead. You're not spinning up a new PowerShell process and loading in all DLLs and type information, all that stuff that you would get with a PowerShell job. And because it's in process, and that's also another important thing. It's in process versus out of process, so it's less to work with. When you use a PowerShell job and run commands such as get process, anything like that, what you return back when it's completed is actually serialized in types. So that means you don't have access to all the methods that are available in the actual type itself. And depending on what you need to do, you can actually share variables between each of the run spaces or the threads, and basically you can update one that can be read into another run space and vice versa. And another big thing is also the capability to throttle your commands. You could run against 200, 300 systems, and you could throttle it to only run 10 at a time. So as each run space is closed up, the next one will pop in and run the next command. And depending on how you configure the run space, you can configure it to just use the same threads each time, so you're not creating multiple threads more than what you need for it. Now, with the pros come with run spaces. It's not really for beginners. If you haven't used PowerShell that much, you may find it so complex. So that it's very developerish. It's more like it's closer to the C# language in that aspect, because you're creating run spaces, you're tracking them, you're adding things into them. You have to monitor the run spaces. You have to properly dispose of the run spaces when you're done, and all that stuff. The documentation is pretty sparse. MSDN is pretty much your best friend when you're trying to find that information out on run spaces, run space pools, the PowerShell type instance, and all that stuff. Also, the manual maintenance that you need to either spin up a background monitoring job for the run space or something to track all the information, or you have to make sure you handle all the run spaces accordingly. And with that, the reason why is because you have potential memory leaks. If you don't close up a run space to dispose of the PowerShell instance, you have all the data just sitting there and taking up resources on your machine. And once you get your dispose of them, garbage will kick in and eventually bring that memory back into the system. And same goes for the variables. Depending if you're using synchronized variables and all that stuff, you need to make sure you track those and clean those up as needed. There are a few ways to create the run bases or to utilize them. The first one is actually using the PowerShell instance. And if you use the create method of that, it will create a PowerShell instance with the run space ready to go. You just need to add some information and let it go. If you want to get more granular with it, with the run spaces, you use the run space factory. And with that, you can do the create run space method, which creates a single run space that you can then modify it to suit your needs and then invoke a command. The run space pool is where you actually go and create a run space pool, supply the throttling, the min throttling, maximum, and a few other things I'll discuss later on to the run space pools. The create out of process run space is, I won't cover that, but basically that's what it says. It creates a process outside the run space. It's slow because you have to supply type information into it, and it more or less kind of defeats the purpose of the performance edge with that. So with that, I'm going to get on with the first demo to actually show you how to build a run space, how you pass arguments and parameters into it. I'm showing you kind of the thread count as the run spaces go on, as well as showing you the async approach, which allows you to do essentially background run spaces. Okay. So the first one is, I'm just going to show you how to use PowerShell type to create a PowerShell instance. It's simple as that. We can look at the membership using all the properties methods of this PowerShell instance, and you'll see there's quite a few things there. You have a bunch of methods, anything for adding arguments, commands, parameters, script lock, as well as if you view the PowerShell itself.
Hey, Bo, I'm sorry, maybe I missed it. What are you instantiating a PowerShell host, or is this just
Yes.
Okay? So, but this is in the background.
Yeah, you're basically creating the PowerShell, like almost like a host on the current PowerShell process.
Okay, so if I was building out like a C# web form or even a WPF app, this is kind of how I would kick off PowerShell from those platforms.
Yeah, absolutely. Yep,
Okay. Okay.
absolutely. You'd be basically calling the system management automation by PowerShell and using the method there to build out your PowerShell host. Absolutely. And you see in the actual project you can actually have your commands, your streams, Runspace, a bunch of things you can do here with that. I'm going to show you the Runspace itself. And you can see the thread options. Typically default, so you just keep default. You have a couple options like a reuse and I believe it's create new. If you're using a Runspace itself, default is the same as creating a new thread. Whereas when you do run spaces, the default would equal reuse thread. So you're not just spawning a bunch of threads. And we can see with full language mode, we're not using any constrained language off the bat. We're opened up, it's available to use. We can pretty much just go ahead and dive a little deeper into the configuration of the run space. And this is kind of like the step state. Here's where you have all your commandlets, all your assemblies, all that information here, and you can go and view it, modify if you need to, clear things out, however you want to go about to configure that session state. So with that, we can look at a couple of one-liners using the PowerShell instance to just run some commands. And basically, we'll use the add command method. You just apply the name of the commandlet, and then with that, in the same instance, we just call .invoke to invoke the command. And with that, we get our path. If we want to go deeper into it, if you add parameters and all that, we can do the add command, do .add parameter. We provide the parameter name first, followed by the argument for the parameter, and you just chain those together as you need. And at the very end, call the dot invoke. Obviously, if you start adding a bunch of parameters, you're going to have code that stretches way up beyond what you really want to maintain. So what you can do is you can create a hash table of parameters that you want. And then instead use the .add parameters method for this instance and just apply an index set hash table. So you would actually look into this. A list or a dictionary or hash table. So I like to go with a hash table, easier just for me to track. And the same as we did with before we run, I have to actually create the hash table first. And the same as before, just we have it a little bit better looking, and we're doing the exact same thing. The add script method is probably a very popular method because what it does is basically we can define a script block and then use .add script, supply the script block, and run the command as well. So in this case, we're going to create the command, we'll create the instance, we add the script, we want in there, in this case, get date. And what you can notice is when we add that in there, it's going to return back the PowerShell object. So we can just let that to out.
Sorry to interrupt again.
Yep.
I don't want to go through the whole thing and having it pop in and out. Does your PC have a microphone? Maybe it's just the headset that's just disagreeing with us.
Okay, I can try. One sec.
Like every fourth or fifth syllable, it just goes like, the crazy.
Yeah. It's probably the connection, because I know even like when you were talking, it's kind of spotty, off and on.
Yeah.
I could actually try to do a reboot maybe and see if that might clean something up. Let me switch out of
We
this.
can keep it here, so. Yeah. Yeah. You think it's the Wi-Fi? You want to try? He's. Oh, are you on Wi-Fi
Does
at
that sound
home? Or are
any
you
better, any worse? I am on Wi-Fi.
Okay.
I can spin up maybe a live connection to go fast to see that helps.
Maybe.
It sounds like microphone.
Yeah, I think it's the microphone. Yeah. I mean, we hear you fine, and then it's like, exactly, it gets to a point, and then it just wonks out.
I imagine part of it might room. We're talking the room then. Microphone partner speakers.
So it's pretty choppy even now then.
Yeah, it's still popping in and out.
Let's see. Is it still pretty choppy even now when I talk?
Keep trying a little more.
Anything now? Sound better? Sound worse?
A little better.
No better?
Yes. I will put me on mute again, and if you could just go ahead, and I'll tweet you if everything, either way, whether it's good or bad.
Okay, that works, man. We'll go from there.
Perfect.
Okay. So it returns back the object that, and we can just like outnull that or avoid it or whatever just to prevent that from popping up. And once we do that, we can actually run the ps.invoke again and give it a run. And we have our date popping in now. Now, it gets a little more complex, trickier as you start to add variables into it or parameters. So in this case, I'm going to have a param1 and param2 with two different values. I'm going to go ahead and add those in and actually try to run the command. Okay. Oops. Okay. All right. There we go. Okay, so I run that invoke again, just kind of show you that we do have the get date. It does come up. And as we get with the parameters, if I just run these as is and try to put the parameters I created into the script block, what we're going to see happen is that there are no values put back to us. And the reason is that because you have to supply the parameters into that. Now, if I was just to a regular script block, it works fine. We will see that we have our values, but because we're doing it through the PowerShell instance, it's a different scope. We have to handle it differently. And that way is by doing either dash. In this case, we'll do the add argument. And there is some important stuff with this, some gotchas with it, but I'll show that in just a moment. So we're going to go ahead and I'm going to do what I did before, create the instance, add the params, but this time I'm going to chain together some meta arguments for param1 and param2. I'll do that, and then I'll go ahead and invoke the command, and we'll see that we now have param1 and param2 showing up. So order is very important when you're using the add argument parameters or methods. You have to do them so if I have param1, param2 in my param block, I have to supply those in the exact same order with my add argument methods. If I don't, in this case, what we're going to see is param1 is not going to equal what we thought it was going to equal. It's now swapped around. So a workaround for that, if you don't want to deal with that, you can actually use the .add parameter approach. And just like I did with the .add command, we just add the parameter names in there with the parameter value. It's not going to matter what order it goes in. It's just going to go ahead and use our param statement on the script block and output it like it should be. Same for the parameters approach, just like we did before with the hash table. We'll supply that into the same thing, and we will call the code again. And again, we have our 10 and 500 back where they should be with param1 and param2. So, and we can actually see we can see the threads that are running within the PowerShell process. And typically, depending on how it goes, you can actually see the actual thread count go up by 1. And sometimes it's tough because it just depends on what's hitting the process at a current time. So right now we have like 15 total threads. We're on that, so we're actually using a thread ID of 9, and our PID's 5116. So typically, in this case, it's going to stay at 15, so that's good. And sometimes it bounces up, bounces down. But in this case, I'm going to create my instance. I'm going to add the script block, which is going to still show the exact thing I showed before with the ID, the PID, and the total threads. And we're going to invoke it, and we're going to see what happens with it. So what you're seeing here is that we have the same process ID, but we have a new thread ID, and our total threads went up by 1. So if we go back and look at it again, it should be down to 15. If we went back down to 15, we're still on our current thread ID. And if we try to go with PowerShell jobs, what we're going to see is something completely different. Same exact process. I've got my thread count, my thread ID, all that good stuff, but now we'll do it through a PowerShell job. And we'll wait for that to finish. And as you can tell with PowerShell jobs, it takes a little longer to set up the job, run the job, and tear the job down. And this is a prime example of the speed difference between the two. So now we have our job done. We have a completely different process ID, and then of course a different thread ID, and the thread count is of course going to be different. So the real meat of this is going to be the asynchronous approach to doing this. And that is done, it's a slightly different process. We have a non-async approach, which is, dot invoke. And I'm going to run this. It's going to go into sleep for 2 seconds and then show us date. So right now, we're just waiting on that, and there it shows up. The difference is with what we can do. The async approach is that it's calling the begin invoke method. And what that's going to do is it's going to not only kick it off and give us back our console, it's going to kick up a type, the async resolve type. And what that does is that we need this in order to successfully close out the process when it's all said and done. If we don't have it, what's going to happen is we're going to essentially have something in memory that we can't get rid of unless we actually close down the PowerShell console. So we'll look at it again, and it is completed. We can tell the property is completed, that it is done. It's ready for us to go in and watch. And during this time, while we wait for it to finish, we could, just run any command like get process and just, let it do its thing while we wait. So, and what we'll use is we'll use the PowerShell instance, and we'll call the invoke method, and it requires the async result, which is the handle variable that we have. So we'll go ahead and call that, and it immediately outputs the data that you were looking for. If you have objects that will be outputted by this, they will immediately come out once you call that invoke. And there are a couple of gotchas with that. If you have like a non-blocking call of some sort, like if you're doing some kind of a data mining query or some kind of remote decom query that locks up and it's stuck hanging on that, trying to retrieve that data or make that connection. If you try to end that handle, it's going to lock it up. It's essentially going to be a lost cause to try to get it back. And at that point, you are going to have to close the console and redo it again. It's one of those things I haven't quite figured out how to get around it yet. You can call it like a begin invoke or a begin stop on the PowerShell instance itself, but it never really stops.
Oh, I have a couple quick questions.
Okay.
Is this a separate PID altogether than the console you're in? So I presume it's a separate process ID.
Which one was it again? Sorry, kind of breaking up.
Oh, sorry. The handle, that the last job you ran here.
Yeah.
Okay. So I'm guessing that's a different.
Okay, that other handle. Yeah, that's.
Okay. Sorry, it's a little late. Yeah. So here, you know what?
That handle is it's different thread.
So, Bo, I'm just popping the questions in the chat. So that just might be easier because there's so much echo back and forth.
Okay. Okay, that works. Okay. Okay, to answer that question, if that's a separate process ID in the PowerShell window and locks up, can you just run stop process on it? If it is a separate process ID, you could do stop process on it and do a force to kill it. But if you're running but since everything, all the background run spaces, those threads are running, and that's just a thread of that process, you will take out everything else with it. good.
So basically what we're trying to get at is, what's the main difference between this and a PowerShell job?
The main difference is that these are all in process, and there's less. You have a greater performance increase when you're running the commands versus a PowerShell job. With a PowerShell job, you have to spin up the process, allocate the memory for it, as well as run the commands, and then the teardown also takes some time. So you're looking at about 50 meg per PowerShell job that you run at a time,
So it's
it takes
instantiating a whole host of executables for a PowerShell job, right?
Yeah, yep, exactly. There's more. Yeah, with a PowerShell job, you've got a lot more overhead coming in than with a if you do like a Runspace. Got anything else? Okay, go back here. Okay, so once you're actually done with the creating the process creating the instance, and actually run the invoke command and invoke to close out the job and get the data back. It's important that you perform cleanup afterwards. So you need to close the run space, and you need to dispose of the PowerShell instance. And once you do that, it will actually allow you to reclaim the memory through garbage collection and get that data back. And then another piece, and so using the PowerShell jobs, I kind of hinted this earlier, is that it returns back serialized data versus live objects that have methods that you can use. So in this case, I'm going to spin up another job and just call get process on it and wait for it to finish. And once it finishes, we'll take a look at the actual object type and see what it comes back as. And what it'll come back as, it'll come back as a deserialized dot. I think it's like system. Oh. Am I still sharing? I am. One sec. Okay. Sorry about that. Okay, so we got the data. We look at the objects on that, and what we see is it is a deserialized object, system.diagnostics.process, and when you have serialized objects, you only get two methods really: get type and toString. You don't get any of the other methods like .kill and all that other stuff that you would normally get with a typical live object. So doing the same thing with the run space, we're going to, once it's done, take a look at the object and see what we have. And we're done. And if you notice, that took a lot faster time than what it did with the background job, with the PS job. And if we look at this, we're going to see that we have a live object now.
Well,
okay.
Yeah, camera's back on you. You need to share your desktop.
There we go. Okay. So we ran the job, the background, the Runspace. It didn't take much time at all to complete. And unlike the PS job, we get back an actual live object that we can view. And not only that, and that comes with the methods that we could actually use, like close main window and all that stuff. Those are the things that you wouldn't see with the PowerShell job itself. And the next piece that I'm going to show, we've pretty much done mostly things for the PowerShell instance, but now we're going to come back and actually look at the Runspace factory and actually create a Runspace to use. And we use that using the Runspace factory and the create Runspace method. And with that, what we do is we can designate the department state, thread options. In this case, we keep default, all this stuff default. We don't need to do much with it. Key thing to do is to actually open the Runspace so that we can actually make use of it. We will supply it into the Runspace property of the PowerShell instance and do what we did before. We start adding script block into it. We'll invoke it, and then we'll wait for it to complete, and then we'll see the result. And we got back a result, it's a live object again. So it's pretty much the same as doing the PowerShell instance. It just gives you a little more customization on the thread itself. So and now we're going to Runspace pools, and this is probably my favorite part about the Runspaces is that this allows us to throttle the Runspaces. This gives us our ability to say, okay, I only want 10 going at one time, and I can run against hundreds of machines or systems or hundreds of anything, and it's never going to exceed the threshold that I give it. And the Runspace pool itself, we'll call create Runspace pool. We'll supply 4 values for the parameters. The minimum run spaces, typically just 1. I've never really gone over more than 1 for a minimum run space. The max run spaces, this is actually where you throttle the amount of commands running at the same time. The session state will create a default one, and this is what you can use to define available commands, variables, and things like that you want to supply to all the run spaces that spawn from the run space pool. And then we're going to supply the current host as well to create the Runspace pool. So this demo is going to show us how to create the Runspace pool, applying it to the PowerShell instance, tracking the Runspace pools and jobs, reusing threads, and showing how you can inject a variable through the session state that all the Runspaces can share. So create a Runspace pool, we can look again, we can just kind of see what is involved with it. You have a few different, there's a lot of different possibilities how you can create the object. I typically go with the example I showed, the min, max run spaces, the session state, and the PS host. And to create the session state, we'll use the system.management.automation.runspaces.initial session state type. And we'll do a create default. And what that's going to do is that will give us our default session state. And you look at it. We'll see that we have a lot of stuff. We have a language mode. We can look at modules, assemblies, types, commands, variables, all that good stuff. Looking at the object itself, we can actually import modules into the state. Whereas with a PowerShell job, you would have to go for each job created, you have to import a module for every single job that pops in. With this, we import the module one time for that session state, and it applies to every single run space that uses that run space pool from now on out. Pretty handy to use. Saves you a lot of time. I'll actually show you how to inject variables into it in a few moments. But we'll take that, we'll create the run space pool. I'm going to give it that session state. I'm going to use my PowerShell host, give it the 5 max. And now we've got the run space pool. So, not a lot different than what we saw with run spaces. You have a cleanup interval that will dispose of the unused run spaces for every 15 minutes, I believe. Yeah, every 15 minutes. And there's a couple methods on the side that you can use during the process as you're adding commands to running run spaces. You can use the get available run spaces, and that will tell you how many run spaces are currently open to be used. In this case, we have 5, all of them open right now. We're not actually using it this time. And then you'll go ahead and you do the usual stuff, create your PowerShell instance, and add the run space pool into it. And the important thing is you cannot actually add both the run space pool and a run space to the instance. One will overtake the other one. So what we'll do now is we'll actually go through and run some commands. Actually go through about 50 iterations, and we'll show you how this will go through and run, and we'll see.
So real quick, can you bump the font up a bit?
Is that good? Go better?
Great.
Perfect. Thank you.
Awesome. You're welcome. Thanks. So here I'm going to add a few things in the mix. I'm going to have some param statements as well, just to kind of give you an idea of the params, like injecting, a new parameter. I'm going to go with the thread ID again because I want to see what the thread ID is, same process ID. We're going to do some random sleep cycles, so that way it's not everything just going at once. Sometimes it's going to take a little bit longer than others to finish. I've created a jobs list, because once you start dealing with run space pools and multiple run spaces going in the background, you have to have a way of tracking that stuff and making sure that you're not losing any run spaces, and you're not going to have anything sitting around in memory that's just going to take up resources. So I go through, I'll create that, I'll add the parameters, I'll begin the invoke of the command, then I'll just add those, both the instance and the returned handle into the list and go with that. And I'm also going to have some debug statements so we kind of track the status of it during the initial run. Let's see, right here, kick it off, and we're going to see that we begin with thread IDs. We have run space. We have 9, now 8, and it slowly starts going down with the variable run spaces. You'll see the thread IDs as some begin and end, as certain ones like 17 ends, so it'll kick back on with a new run space, and eventually you'll see the run space pools potentially go down to 0, depending on the function of the system, how fast things get done. It may never get to 0, or it may not. It just kind of depends as things finish up. But eventually, when it finishes up, we'll be able to go through and check and look at everything. So, and as we get closer, it's still ending. And at any time, we can check and see where we're at. And now we're done. We have our 10 run spaces available, and we have no more jobs left in the queue. So now we'll go through each one of these and make that clear. We're going to go through each of those items in the job. We're going to get the data back, the objects outputted when we call the invoke, and at the same time we're going to dispose of that into that instance. That way we get our memory back. And then we're going to turn that jobs out just because at that point we no longer need it. So go through and run it. It's done. So we can look at the return data, and you see the same process ID repeated, the same params that we supplied, different sleep cycles on the far right, and the direct middle, that's our thread IDs. So we're going to group these, and we should see probably 10 of them. 5, yeah. So we have our 10 thread IDs right here. So we probably stay within that 10 max run space limit on that. And if you wanted to prove that we're using the same process ID as our host, we can see that we actually are still using that. The last piece on this demo, on this one, is basically injecting a variable into the run space pool. And what this is this is a way of, okay, I want this constant variable into each run space pool, into the run space pool for each run space so they can reference it. And it's different than doing a param, because a param you can do like a dot add argument param. They can actually change those on the fly and as you're iterating through each item. And this one is just static. It's not going to change, but they need to reference it. So I've got my throttle. My test is going to be my injected variable, and it's just going to be a string of numbers. What we're going to do is it's a little more work to add those into that. You create a session state, but then as you add the variable in, it has a specific requirements. It needs to be of a certain type. So we have to actually create the object, and we'll supply the arguments into it. In line 99, we'll create that object, supply the argument list, in which case I'm calling the name of the variable first, test, the value of the variable, and the null could be a description if you want it to be that. I don't really need it to be a description for this. So in that case, I'm just going to leave it alone. Look at it, and we see our information. We see the object there. And it's basically the same as we do before. We add the variable into the session state. It's now in there. We could actually look at it and verify it. Oops. And as we verify it's there now. And from there on out, it's essentially the same thing as we did before. We'll go ahead and create our run space pool. We're going to go ahead and add everything in, run the code. And this time, the only difference is that we're just going to return the value this time, just to prove that it does work. We'll kick it off. We'll let it go. Shouldn't take too long. And done. So now we go through and I'm going to very quickly go through invoke. I'm going to dispose of everything, and I'm actually going to call that last because that could cause issues. We're going to return the object. I'm going to create a custom object. I'm going to actually call the invoke right in the get system object, and we'll see that we'll have the same data for each job that kicked off. So the string is the exact same thing for everything. That runs all those run spaces. Of course, we'll dispose of the run space tools, so we're not keeping anything that we don't need. So I kind of hinted at sharing variables early on, and the approach to that is it's a thread safe collection, which means that you can push it to any thread or run spaces in that PowerShell process or host, and not only will each of those run spaces have access to read from it, but they'll even have access to write to it and add and remove data from those collections. And I've got 5 different collections here on the screen: hash tables, array list, and array, queue, or stack. My most common one I use is always hash tables because I can basically define essentially a variable name and the value doing that. It's very useful, especially once you start working with UIs like WPF and WinForms. They become even more valuable. As I said, if you write to a different the variable collection, you have the possibility to impact another thread that's using that reading from it. So there's definitely some caution that has to be done with that. And another issue is they call it a race condition, where if you have a thread trying to write to a shared variable collection, and another one's trying and another one goes and tries to enumerate through it, you're going to get some errors that pop in because it's going to say that this object was modified during enumeration. It's going to error and cause potential issues with your code. And to get around that, you can use the system.threading.monitor and use the enter method, which you can then supply the .sync root property of that collection. What that does is that locks it to only that thread, and anything else that tries to access that variable, it will be basically sitting in a queue to get access to it until I call the exit command. And I'm going to go into a little demo of this. I'm going to show you how you can share them across different run spaces. There's a couple different approaches based on if you go to the Runspace or Runspace pool, how you can add those into the run spaces. And also showing you some demos of actual locking of those collections and what happens if you don't lock them. So creating a synchronized collection, you essentially call the type name of that collection, and you can call the synchronized method for that, and then it takes the argument of that collection type. So if I want the hash table, I will call the hash table type synchronize, and I supply an empty hash table. Same for same for an array list, and same for a queue. You create those, and then you can start injecting them into your current run space. So right off the bat, I'm going to show you that, again, PS jobs, they don't allow for synchronized collections. It's totally different process itself. It's not on the same thread, so you won't get that capability with this. So if we kick this off, we'll see hash.1 is 1 before the job. In the job, I'm going to have it increment by 1. Then I'm going to check it again when it's done. And after checking it after the job, after we incremented it, it's still a 1. It's got a value of 1. So this right here, even though it may have worked inside the job and incremented, it didn't matter outside that job, unless we would have actually called receive job and return object back out. With the run space, we're going to do the exact same thing. We're going to create the collection, create the hash table. We're going to give it a value of 1. We're going to increment it, close everything out, and then we're actually going to look at the value again at the end and see what happens. And we can see that the value actually did increase, and the value that happened inside that other thread is reflected in our current thread. It's now updated by 1. So this one, I'm going to actually run in the console. And what I'm going to do is I'm going to show you how to, and basically the way this works is with the runspace itself, in order to, and how I'm going to add this in, I'm going to add this in through the session state proxy set variable, and I'm going to give it that variable name and supply the actual data into it. It's somewhat similar to what you saw with the runspace pools in the initial session state where we had to add the variable. This one's a little more easier to use, but again, it's only limited to that current runspace. So I'm going to kick off all the stuff. I'm actually going to use a queue this time. I'm going to add about 50 numbers into it. We're going to see on the title on my console. I'm going to try to adjust this a little bit for you guys. Hope I can make it a little bit better. That didn't do anything. Bump it up a little bit. So I'm going to run this in here because I'm going to take advantage of this tile bar right here, and as you can actually see the countdown, the things DQ and all that stuff. So I'm going to kick this off. And now you see on the top, you have the queue count, the current item, and the next item in the queue. And that's slowly going down as we work through this. So what I can do is I can actually inject more numbers into it. And now I'm not up to 50 again. Now it's going through again. I can actually go through and clear it out so it's completely done. And there's nothing left. We're down to no queue, no current item, nothing like that. And if I want to, kick it back off. I can even, and I'm using, and that I didn't mention that, I'm using a background run space to handle all this information, all this stuff that's happening. So what you're seeing here is line 49 through 71 is the background run space. It's in the background. It's basically kind of like a job monitor almost. And so basically it's just looking for information, and if something exists, it's going to act upon it. I've got in my hash table flag, I have a flag set to true, so that way it's going to just continue on and keep looking for things until I'm done with it. And to be done with it, I'm going to change the flag to false, and what you're going to see is now, well, we call in the right spot. And what you see is the queue just stop. It won't process anything else. It's going to be stuck at 20, and it's not going to go any farther with it. So that's a way, if you've got a background kind of a monitor thing, use some kind of synchronized hash table, give it some kind of flag, and that way, if you need to stop it, you can stop it, and that way you won't run any issues with trying to dispose of that run space or that instance. So same as before, I'm just going to close out everything. Okay. So some of the same stuff here. We're going to kind of the same thing. I'm going to kick off a run space. I'm going to kick off my background job, and we're just going to kind of track everything, see how things load on it. And what I'm going to do here is I'm actually going to initialize. I'm going to force error to happen. I'm going to start writing the things while this is trying to write to it or enumerate through it. So at the beginning, I'm going to kick off the same type of job. It's going to go through. It's kind of like a monitoring thing. It's not going to do anything. We won't actually we won't see anything really popping in just yet until we start actually trying to inject data into that variable. So to really show this off, I'm going to try and just do a while loop, and it's just going to go through as fast as it can and just start adding stuff into it. And so we'll see a ton of jobs come on, but we're also going to see some error pop in eventually. So as you see right now, we've got errors popping in. Jobs are flying like crazy, starting to try to do stuff. But it depends. It's random. I mean, you never want to put yourself in a position to have the stuff basically try to modify while it's going. It creates issues. It could cause havoc in your code and all that stuff. So definitely, so the trick to get around this is to use the lock object approach, which is to, again, same thing, but we'll do a little different this time. We're actually going to, while that job flag's going, if it finds anything, it's going to immediately call the enter method for the frame monitor. And it's got a few different approaches to it. It needs the object and a reference of where the lock was taken. Not really too important, but I have it in this demo. And what it's going to show is that it's going to take ownership of it. It's going to lock the object, do what it needs to do, then it's going to come back when it's done, it's actually going to unlock it. And while it's doing that, I'm going to go ahead and do the same thing here. I'm going to do the same while statement. I'm going to start injecting stuff into it, or trying to, and we'll see it go through, and it will either wait for the lock, take the lock, or and just do a bunch of different things. So before, it doesn't kick up yet until I actually kick off my next statement. And here we go. We're going to kick this up, and we're going to see that as it goes, it locks it, unlocks it, it looks for jobs, it keeps tracking the jobs, and it'll keep doing this. And the --RS is the actual Runspace itself, that job monitor doing the lock and unlocks, and the jobs colon by itself is the while statement doing the stuff. And eventually, I mean, each time it takes turns. Once it's done, the other one kicks in, and so on and so forth. It's a great way to avoid those type of issues with locked objects. So I'm going to head and stop that. And just clean up. And sometimes, especially where we're now, there's always a possibility of backups with the console or the ISE. It's still maybe trying to do some stuff I was given a lot of things to do, so it could freak out and close up on me like that, lock up like this. So it's not a big deal. We'll just go ahead and kill this ISE, and we'll bring it back up and continue off from there. And the last piece I'm going to show you with the collections is just there's also a try enter and try exit method. And with that, what you can supply is you can supply an additional parameter to give it a 10 milliseconds to wait and then time out if it can't get to it or not. So if you don't want to wait for it, you just want it to move on and continue on with it and come back to later on, you can absolutely do that. So So once that comes back into those scripts, we'll go ahead and start back off here. And same thing before, we have the same setup, except now we've got try enter, and it just takes the same type of frames, except you have that milliseconds timeout. Slightly different. So I will kick off this. And I'm gonna have this sleep for like 1 second. That'll be more than enough time for see when I attempt to take the lock on that object. Off. Good, and now we'll go ahead and do the same thing. And same situation here. This has a 10 millisecond timeout. And you'll start seeing it's locked. You'll see some warnings pop up, or that's unable to lock an object. That just means that it's trying to deactivate 10 milliseconds. It's still in use by the Runspace. At some point, it will eventually connect to it and actually take it. In which you did just now, we took it, did what we need to do, and now we're going back in and waiting for it. So another approach to it, to handling with the synchronized objects, but again, important to have. If you are using synchronized objects, anything that, whether it's going to be any type of write attempts on both sides of the threads, any threads, you absolutely should lock the object, have some sort of implementation to do that. All right, I should give enough time. See if we did. Good. Okay. So, I mean, and the question is it better than a PowerShell job? Well, the answer is always it depends on what you're using it for. If you want speed and you want performance, you go with Runspaces. The ease of use is definitely with PowerShell jobs. I mean, the PowerShell team's done an awesome job putting that architecture together to have a job system that you can just quickly, with a couple command lines, go through and run stuff in the background and check back on it. If you have memory constraints, Runspaces are definitely a good thing to do because PowerShell jobs, they do take up resources. The more you have, the more you use. So it's a good thing to keep in mind. And if you actually need a live object or not. Do you need to have that object live so you can actually use those methods? Or can you handle getting a serialized object and just going with that? And another thing is variable sharing. Do you need to have variables shared between different avenues? So now I'm going to go into the performance piece of this, and this is I'm going to show you the memory utilization of PowerShell jobs versus Runspaces, the time to complete, how fast one does against the other one, and then just for fun, we're going to look at the PowerShell instance create method versus Runspace pool, and just kind of see how they stack up against each other. So the first one on this list is going to be the PowerShell Runspace console script. Okay, so I'm going to run this guy in the console, and we're going to see essentially just not so much how fast it gets done, but the memory utilization of Runspaces that we have going on here. And if the same thing's going to happen, I'm going to have the title bar. It's going to be kind of used as our metric to watch and see what happens. Here. Okay, so I'll kick this guy off. We have our starting memory. We're going through, running, I think we're doing 50 iterations of it or so. 100 iterations of it. And as run spaces go, and this is mostly just to build the run space up and tear it down and use that. I mean, the time to complete for 100 of those took, 7 seconds. At most we used was about 13 meg of memory. We peaked out at 95. We didn't really use a lot of memory in this. We didn't use a lot of resources. So on the flip side, what I'm going to do now is I'm going to show you the PowerShell jobs approach of that and how that fares with it. So as this one, I'm actually doing all these. I'm going to have 2 columns on these because I've found with the ISV it tends to hang up. Call up another one. I want to make sure I'm only grabbing the other processes that are being used, not the current processes of either console. So right now, and there won't be anything popping in the tile here. It's all going to be on the console itself. So we have a total memory right now, nothing. Peak is nothing. So we're going to go ahead and spin up uh, 10 jobs. We're going to just keep it simple. And as these kick off, we'll start seeing things pop up. And I mean, already we've gone on our peak of the run spaces. It keeps going, and eventually when we get to 10, which will equal the amount of threads we had doing one time on the run spaces, we'll see we'll hit a pretty decent peak of memory being used. So right now we're averaging, about 54 meg per run space at this. I mean, per PowerShell job at this point. So it's pretty expensive. You definitely need to make sure you have a system that can handle it, and that you are not spawning too many PowerShell jobs at one time. Otherwise, it will come back and it will slow down your system and make it very difficult to do things. And because and also what we're seeing now is we're seeing the slowness involved with it of it actually shutting down the jobs and breaking them down. So once they're completed, so it definitely takes some time. We'll check back on that in a moment. See where it's at. So the next one is going to be an actual time for stuff. Same thing. We're going to have 10 going at one time. In fact, because of that, we're actually going to go ahead and kill these off. But you saw with the run space, it took about 7 seconds to do 100 threads at a 10 thread maximum time. Now we're going to do the same thing. We're going to have 10 jobs going at one time, and we're going to see how long it takes to do this. This could take some time. So as that's going, prep for the next one. And start. Okay, yeah. So as we wait for this to finish up, and this could take a while. You got to take account that it's making new processes, it's taking on more memory, it's competing with already existing things right now. But I mean, you tell me we've already gone beyond that 7-second window now. We're probably, we're who knows how many seconds into it now, and it's trying to spin those jobs up, run a simple command, and then break those jobs down as well, and present the data back to us. So it takes some time. It's absolutely not the quickest approach, but again, it's simpler. It's more about simplicity at that point with the PS jobs. So we'll come back to that one later on when it's all said and done. So this is some code. It's Tobias wrote another PowerShell VP. This is kind of borrowed code from him. I took his code that he kind of used and kind of made my own to show some various avenues of doing the PowerShell, doing PS jobs, and breaking it down by the time it takes to launch, to exit, to run the command, to receive the data, and the total time it takes to actually run it. So this will give you kind of an indication of what this is trying to do. So keep in mind this is the PowerShell job first, and we're going to run that. And I have all these code examples available on my OneDrive page. So like with some of these, just they're resource heavy to run, and you can run them on your machines and just see for yourself just how these are doing, how long they take. So okay, we're done with this side. 15 seconds to set it up, 15 seconds to close it out. One time was not that long. Received too little time. But 30 seconds total for one job. That's why these are running. So the time will be a little bit different if those other jobs were not running, but it's still a long time. So to go with the Runspace approach while the jobs are running, just for the sake of showing that off as well, we kick off same exact stuff, same exact situation. We're doing the same thing, same test and all that stuff, just spinning up the Runspace and exiting it. And this is definitely under heavy resource, so it's going to be a little bit longer. But it took less than half the time of that one. 13 seconds versus 33 seconds, that's about a 20-second difference. And if it wasn't such a heavy load, it would most likely take longer. In fact, I'm going to go and kill this off. We know that this is taking forever. That we've definitely hit a lot of issues with resource. So if I could run this again, I'll run both guys again just to kind of give you a clean example of it. So under less resources, it takes less time, 3 seconds for that run space. Oops. For the run space, if we go back to the job just for the sake of being fair with that and giving it its due, we'll go ahead and rerun that under more lenient conditions. But even now, you can see the job is still taking some time. And still like 14 seconds to do a job. So we're talking, 11-second difference still, so roughly the same amount of time. So still pretty intensive. The biggest kills of this are the setup time and the breakdown time. When compared here is, it's even less to do that. And just for the curiosity's sake, we're gonna go and just kind of look at each type of run space. So you saw there was the PowerShell one, which was about 3 seconds. We're gonna look at the doing the run space, creating the actual run space, and then supplying it, and then testing it. which is a little bit faster actually than going through the PowerShell route. It took about, about a little over 1 second to run that command. And the last one's going to be with the Runspace pool and just see how long that takes to run. And it's a little bit faster. And, the speed could be different. It could go either way. They're pretty much kind of on par for the same type of speed. It just depends on how much of the laptop resources are being used at that given time. But the Runspace creation and Runspace pool creation beat PowerShell instance, which then also beats the PowerShell jobs. So definitely some things to keep in mind when you're building out your Runspaces, that as far as a performance approach, which one's the best way to go about it. So these are going to be, this is the a Runspace pool demo versus a PS job queue and a PS job throttle, where those two try to simulate a throttling mechanism that you would see with the Runspace pools. The PS jobs may take a while to finish based on the resources. We may see the same instance that we saw before with the 10 at a time, where it may just be just a bunch of it to handle, too much for it to handle given the current environment. So I'm going to basically do 50 of these. I'm not going to have any sleep timer, just in and out as fast as I can go, and we're going to see what we end up with. And this is only using 5 threads at a time. So it's going to kick it off. And of course, in this case, since I measured the command, I'm not going to give it back. It won't give me the console back. It's just going to take it and run with it. So eventually it will finish. And as that runs, I mean, it could take a while. I may not actually show this to you because it's just they may not finish in any amount of time. But as the code's available, will be available to you to actually look at it and see what it does, and you can actually run it yourself and see the performance increase, the performance on it. So that did finish up. 72 seconds for it to run, just over a minute for that. I'll try to get these off. I'll get these off in the console and see how they go. This one is a job queue approach. This one takes advantage of a queue that you supply information into, and it uses that to kind of for the throttling mechanism, and it uses a global function to keep into it, keep referencing it, and then it uses object events. So I'm going to track the state of that job, and when that job changes state from running to completed, it'll go through, it'll take out the event subscriptions, move all those other background jobs. Because each of these whenever you do a regular object event, it creates a PS job. So another process that kicks off. So it'll go through, clean it out, and kick off. And as long as the queue is within reason, it's going to kick off another job and keep tracking it until it's finished. The other approach is a little bit shorter, a little bit simpler, but it doesn't. This one, the PS job queue will give you access to your console, whereas this approach will not. It's using a throttle method. It's checking for each count, making sure it's above or it's below the threshold. If it's below the max count, it will add a new one to it, new job, kick it off, and wait and keep tracking it. So we'll give this one a shot to see how it ends up. I'm not confident it will complete in good time, but so we'll kick it off and just kind of see what happens. We'll come back to it. We'll track those later on. So I'm going to continue on with this just to show the next stuff. So really the last piece of this presentation is going to be showing how both UIs and GUIs, both with or without Runspaces, and why you want to use a Runspace to handle the UIs. And the synchronized collections are important here because you'll use those to inject into the Runspace to, that way you know the UI thread handle the UI stuff, and you push all the other operations back to a separate Runspace. And from that Runspace, you can basically use the, there's a dispatcher on most of the controls and property, and that has an invoke method which will actually use to supply the arguments to push data to a specific control, be it a list box, a text box, or anything of that nature. And the dispatcher will then just queue it up and update the thread, update the UI on that thread when it has time. The caveat to dispatcher is you want to keep the code block small that you supply to it, because you start supplying too much data, or you start supplying too much, or any kind of like blocking call or hanging doing iterations on the dispatcher, it will cause your UI to freeze up, and you pretty much kind of defeat the purpose of doing a Runspace. So with that, I'm going to show a demo with and without Runspaces and kind of the benefits of a Runspace approach. There we go. Back. So this guy's still going. He's going to take a while. I don't want to clog this guy up any more than it needs to be, so I'm going to go ahead and kill that. But I mean, as you see, I mean, it's taking a long time for that to run. So I mean, the PS job's performance heavy, but simple. Runspace is more complex, but much better performance. So the first demo is a simple UI. It's going to be on the console thread itself. We had that. If you notice, I don't have access to my console right now. It's been taken over by the UI. The UI owns this thread. I can use. I mean, if I want to run commands from that through a button or some other approach, I'd have to use like the event of that control to push scripts or commands through that approach to handle that, to then push it back to the UI. So it's okay, it's good. I mean, it works, but it's nice to have something that I'm able to do more with. So what I have here is I create my Runspace. I supply my synchronized hash table into that. I then have my code block, my script block that has all the UI information, connecting my controls, all that good stuff. I invoke it, I kick it off. I have my window, but if you look, I also have my console now. I have all that stuff I can do in and one through that console. It's now opened up. I can now do other things with it if I need to. And in fact, what I'm going to do is I'm going to shrink these down a little bit. from side by side. I want to show you what you can do with this. You've seen this is the synchronized cache table. It's now available to me. But I want to look at the invoke method of the dispatcher. So I'm going to call that. And it's got a bunch of different things to it. You can give an action type, priority of the script, how you want it to run, and some other things. I'm only going to be worried about the action block and the dispatch priority. Those would be the most important things to me. So there's a few different priorities you have. Normal is typically the one that I see everyone use, the one that I typically use. It shares time with the UI thread in a big when it can. The action takes a script block that actually references the control that I can dump any element into this. I could run a command. I wouldn't want to run a command on this because I wanted to run outside that and then add the data into it through this. If I wanted to get child item, I could do that, and then I could take that data and then dump it into this and have it reference that UI control. In this case, I'm just going to go to Window, change the color to green because I can. And if you look, and it turns green. So I've basically just now modified or written to this UI from a separate window from my console, completely outside of the UI for itself. The catch with this is if you close down, your IC or your process, whichever one spawned that UI, you kill that process, you kill that thread, and the UI goes away. So it's important, definitely something to think about, and I've actually made some widgets, like a date widget and a couple clocks that use this approach, so I can just kick off a few things from one process, and I have a weather and time and just something simple to work with, and I still have access to my console. So that's kind of fun, but I want to do more with it. Change the colors. Now I have a function date window. Not really a good function, but it does what it needs to do, which is it appends some text to text box, which is going to be some I'm going to call get process or get service. It's going to be random. It's going to be back and forth, as well as kind of toggle the background to black and white. So I will load that function up, and I'll just do 10 iterations of this and show you what happens. So as you see, I'm going through, I'm changing the color, I'm changing the display, all that stuff through my console or through the ISC. Completely separate from from the actual UI itself. And once it's I'll just go in and close the window first, the UI first, and then I'll actually in the Runspace. If I try to end the Runspace first, it's going to lock up the UI, and it's going to just hang there for eternity until I close out the process.
Hey, Bo, I think our brains are thoroughly smoldering by now. Do you have any more demos after these? I think we're pushing 8 o'clock here.
Oh, I kind of bring it up on me with that.
No problem. We're pushing close to 8 Pacific, and our brains are smoldering right now. So, this is actually great. Really awesome.
Okay.
Did you have another? You have another one, or you want to wrap up?
Okay, I can wrap.
Yeah, I think we need a beer. Did you?
Yeah, I can wrap it up right now. I'm just doing the final 2 things, and I can just kind of talk about these. I mean, I'll have the code available to download. But yeah, I'll wrap this up right now and let you. But yeah, the last 2 things here. the basic demos of how you could utilize the Runspaces to run the UIs faster. And I have the one demo here, which is a 521, which shows it without, how long it takes. And 521 shows it with the Runspace. And basically, the difference between the two is the non-Runspace one, you kick it off, and you won't see anything until it's finished. With the 521 script, you'll actually see the UI update as things finish up. And there's actually a progress bar that will go and actually update stuff. So it gives you better fluidity with the UI when you use a Runspace. So with that, you know, we've seen pretty much let's see, all the different approaches to Runspaces and what you can use them for and all that good stuff. As soon as I get to that. Yes, to recap, everything, the Runspaces, great for multi-threading, much faster than PS jobs, great performance. Caveats are that they are more complex to write and maintain. You got more moving parts, you have to handle those accordingly. You can use synchronized collections. They're great for sharing data between Runspaces, but again, caveat that with locking those down if you're writing to them between Runspaces. If you're writing UI, I would absolutely recommend you use some sort of multi-threading to keep your UI free of stuff and to put all your stuff on the back end Runspaces to make things run smoother and have a more presentable UI for it. I do have a project I'm working on that I actually just pushed out before I came on tonight. It's called a Posh PS Async job. It is basically a PS jobs approach, but with Runspaces. I don't have it's very much in alpha stage. There's going to be bugs on it. There's really no help for it right now. It's all going to have. I'm really going to do a full-on public beta release of it probably by the end of the month. But it is available right now at the link provided. You can download it, use it. You know, if you want to give me your thoughts, bugs, any feature requests, all that good stuff. And just some links I reference, you know, just on some of the classes, the collections. I've done like a few blogs with other examples of Runspace being used for different types of scripts and some information about the dispatcher. There are a bunch of scripts out there on the Technic script repository that to different variations of Runspaces and Runspace pools that are worth checking out and see if anything fits what you would like to do with it. And with that, I mean, if I don't have any questions, then again, thanks a lot for having me. And my slide deck will be probably available tomorrow at this link here, or I'll post on Twitter as well, and have all the code examples and the slide deck available.
Awesome. No, Bo, this is fantastic. I'm just, at the point of my learning of PowerShell, I'm just getting my head around where and when I just do the PowerShell job. I didn't have any idea about all this stuff with Runspaces. So.
Thank you.
Yeah, this is fantastic. Yeah.
And you're wonderful. You're a famous guy on the internet.
Thank you.
So we can do that.
Hold on one second. Hold on one second. Awesome, Bo. Well, I definitely appreciate it, and if I can do anything for you in the Omaha music group.
Thank you.
Oh, thank you. Yes, absolutely. Yeah, I made a trip too on the Google Hangout stuff too, just to get an idea of how to do that and all that good stuff. When we get
I'm not an expert, but I guess I have the most experience, so happy to help you however I can.
Awesome.
All right. Thank you very much.
Thank you. Good night.
Have a good night.
Thank you. Yep, thank you, everyone. Have a good night.
Yeah.